Hi everyone, welcome back. Now today we're going to do notes over lesson 7-2, dividing monomials. Now lesson 7-2, there's a few different parts, so kind of probably today and this week we're going to focus on just part 1, looking at the monomials with positive exponents before we start tackling any of the negative exponents. So the rule: quotient of powers. All right, now if you think back to scientific notation, if you have something to a power on top, something to a power, on the bottom, basically just like scientific notation, you are just subtracting the exponents. However, we're going to do a little bit of a different approach. Instead of subtracting, we're going to kind of do a canceling method, because that's what your high school teachers next year are going to do. And so I want to make sure you are prepared for what they're going to have you do. All right. So, for example, let's just start pretty easy. If we have y to the fourth, z to the third, over y to the second, z to the second. Here's what I need you to be thinking in your head. Here's what's happening. In the numerator, you are doing y times y times y times y, 4 of them, times z, z, z. On the bottom, you're doing y times y, that's the y squared, times z times z. Okay, so basically, just like when we were doing fractions and things like that, think of it as we're going to simplify. These two cancel each other and turn into ones. Cancel each other, turn into ones. Cancel each other, cancel each other. So here's what I'm left with. Y squared and a z, all in the numerator. You can put it over 1, but you don't need to. Okay, so think about, and let me show you up here. Remember when you did fractions, if you had 4 over 4, you simplified that to 1 over 1 equaled 1. Same idea, except now with variables. All right, let's do another really easy one. Let's say x to the third, y to the second over x, and let's this time do y to the fourth. All right, so let's look at this one if we were to write it out. Okay, x, and x to the third, y, over x, but now on the bottom I need 1, 2, 3, 4 y's. So then I'm ready to cancel. X for an x, those turn into a 1. Y for a y for a y. Okay, here's what I'm left with. In the numerator, x squared. In the denominator, y squared. That's my final answer. Okay, so now let's try this. So let's try this one without having to write it out, because no, I'm not going to force you to write them all out. All right, if we have m to the 7th, let's go n to the 5th over, let's say, m to the 9th, n to the 2nd. Okay, so now this part I needed you to process in your head. If I had to write it out, I would write 7 m's on the top, 9 m's on the bottom. Where would I have more m's, top or bottom? Should be bottom. How many extras? 2. Because if you look at it, I can take 7 away from here, 7 away from here, and I still have 2 on the bottom. All right, so now let's look at the ends. If I had to write it out, I would have to write out 5 of them on top, 2 of them on the bottom. Where do I have more? On the top. How many more? 3 of them. Because look, take 2 away. Take 2 away, I still have 3 up there. So a lot of the work in this section, so for those of you that don't like to show your work, you should be super happy because a lot of the work in this section happens in your head. Okay, so I want you to try this one. X to the 10th, y to the 4th, z to the 7th, over x to the 2nd, y to the 8th, z to the 12th. So if you would just hit pause, work out the problem, and then hit play again. All right, so here's what you should have come up with. Looking at the x's, 10 on top, 2 on the bottom, x to the 8th, because you can take 2 away from the top and bottom. Look at the y's. Where are there more y's? On the bottom, y to the 4th. And then look at the z's. Where are there more? On the bottom, how many more? 5. And that should be your final answer. All right, let's do one more just to make sure. All right, let's try this one. Now be careful on this one. X to the 3rd, y to the 4th, z to the 7th, over x to the 7th, y to the 9th, z to the 12th. So again, hit pause, try to do the problem, and then turn it back on. Okay, so here's what you should have. You looked at your x's. 3 on top, 7 on the bottom. So you would have x to the 4th on the bottom. Look at your y's. 4 on top, 9 on the bottom, 5 extra on the bottom. Look at your z's. 7 versus 12, z to the 5th. Now, whenever, just like with whole numbers and anything else, if there is a 1 in the denominator, always optional. However, 1 in the numerator, you need to make sure it's there. Okay, because like if you would have written this one out, okay, you would still have a 1 in the numerator. All right, so now let's throw in maybe a number into the mix. So let's look at this one. 3 to the 4th times a to the 8th times b over 3 to the 2nd, a to the 5th, b to the 10th. All right, now for this one, since the base number is the same, they're both 3's, you can approach it just like we did with the others with the variables. Okay, so here's what you need to imagine in your head. 3, 3, 3, 3, 3, 3. Okay, so look at how many you can cancel. Those 3 cancels, those 3 cancels. You are left with 3 squared in the numerator. Now go to your a's like we did. 5 versus 8, where are there more? On the top, a to the 3rd. Look at the b's. Now remember, this is a 1. So there's 1 on top, 10 on the bottom. B to the 9th. Now this one you should take one step further and you should do the 3 squared. So 9 a to the 3rd over b to the 9th. All right, so let's see what you can do with this one. I want you to try this one. Okay, let's go 2 to the 10th times a to the 4th, b to the 7th, over 2 to the 12th, a squared, b squared. So again, hit pause if you need to. And then when you're ready, check your answer. All right, so here's what we have. 2 to the 10th. Now I could write this out 10 times. I could write this out 12 times. Or I can look 10 versus 12. So I've got a 2 squared. Look at my a's. 2 versus 4. So I can take these 2 away. A squared, b to the fifth, and then I do need to take it one step further for a final answer of a squared b to the fifth all over 4. Okay. Now, what if I throw in an extra number? So let's try this one. Let's go 2 to the 14th times 3 to the 6th times a to the 5th times b over 2 to the 12th, 3 to the 5th, a to the 2nd, and that's it. Let's just leave it at that. All right, hit pause, see what you can do, and then come back for an answer. All right, let's see how you did. Look at the 2's, 14 versus 12, so you can take 12 away. So you're left with 2 squared. Look at the 3's, 3. Look at the A's, 2 versus 5, A to the 3rd, and then B. Nobody canceled with B. So now you have a 1 on the bottom, but you really don't need it because I said, remember, the 1 on the bottom optional, 1 in the numerator required. Now, when you take this one a step further, let's see if you got this. 2 times 2, did you get 4 times 3? Did you get a final answer of 12? A to the 3rd, B. If you did, very nice job. All right. Number 9. What if I switch it up and now do this? 3 squared. A to the 7th, B to the 4th, C over 27, A to the 2nd, B to the 10th, C to the 4th. If you want to try it before I give you the answer, just hit pause and try it. If not, just continue playing and go on with me. All right, so here's what I'm going to do. 3 squared, I'm going to change that to a 9. Now, keep in mind, this is still a fraction. 9 over 27. Just like when you did fractions before, you just simplify. 9 goes into 9 once. 9 goes into 27 3 times. So basically what you have is 1 over 3 for the numbers. Now continue with the variables. 7 versus 2, so I've got A to the 5th. Go to your B's. There's more B's on the bottom. How many more? 6. C, now remember that's C to the 1st, C to the 4th, so C to the 3rd. Now your final answer, this is fine, or I would probably take it a step further and do A to the 5th over 3, B to the 6th, C to the 3rd. Because remember, you don't need that 1 in front of the variable. All right. Let me have you try this one. I know the notes today are a little bit longer because there's just a lot of variation in this section. All right. Now I'm going to throw in a negative. Negative 16. X to the 4th, Y to the 7th, Z to the 2nd, over 12. X to the 9th, Y to the 2nd, Z to the 12th. All right. Again, hit pause, see if you can do it, and then come back to the video for the answer. All right, so here's what I did. Now remember, negative 16 over 12. Like you approach this just like you're simplifying fractions. So 4 can go into both of those. So 3, negative 4. So that's your start. Negative 4 over 3. Now the variables you're subtracting. 4 on top, 9 on the bottom. X to the 5th, look at your Y's. Where do you have more? On top, 5 more because you can take 2 away from here, 2 away from here, make that a 5. Go to your Z's. Okay, if you have to still write it out, then do ZZ. Now writing out 12 on the bottom, you might be here a while, but cancel what you can. Z to the 10th. Final answer. All right, so now, are you ready? Remember last section, we had parentheses. All right, so here we go. If you have this, 2x to the fourth y over 3x to the second y to the seventh. If the whole thing is to the second power, okay, here's what's happening. You have to take everything to that exponent, just like we did when we multiplied. So ready? So here's what this turns into. 2 to the second. X to the, remember, it's 4 times 2, so to the eighth. Y to the second over 3 to the second. X to the fourth. Y to the 7 times 2, 14th. Now you're back to the first 10 problems we did where you're ready to start canceling. So 2 to the second, change that to a 4. 3 to the second, change that to a 9. Can you simplify 4 over 9? No. So you leave the 4, leave the 9. Go to the x's. X to the fourth, go to the y's, take 2 away, take 2 away. Y to the 12th, final answer. All right, what if, however, instead I do this? What if I say 2x2y4 squared over 3x4y2 cubed? Okay, so now I have to do the top to the squared, bottom cubed. So here's what I have. Ready? 2 squared. X to the fourth, y to the eighth, over 3 cubed. X to the 12th, y to the 6th. All right, so now I'm ready to start canceling. So I would change this 2 squared to a 4. 3 times 3 times 3, 27. Can I cancel 4 over 27? No. All right, so that just stays. There will be times where they will cancel, and we'll have some of those. All right, so look at the x, 4 and 12. So you can take away. So you would have x to the, what do I have here? 8 in the denominator, and then y to the second in the numerator. All right, let's do one more together. And then lucky number 13. All right. Now I want to see what you would do with this one. Ready? Give yourself some room. 2. X to the second, y to the third, z to the fourth, all over 15. X to the fourth, y to the seventh, z to the sixth, times 25. X to the fourth, y to the second, z, over 12. X squared, y to the third, z to the seventh. All right, now I do want you to hit pause, and I want you to try this problem on your own first. Remember, this is just multiplying fractions. Now, there's multiple ways to approach this. I want you to try and approach and then come back and see what I did. All right, let's see how you did. Now, for me personally, my approach, I like to take care of the numbers, okay? But here's what I did on this one. I multiplied the top, I multiplied the bottom, and then I canceled. So here's option 1. Okay, 2 times 25. So I'm focusing on the numerator. 50. x to the 6th, y to the 5th, z to the 5th. Because remember, when you multiply, you add the exponents. Denominator, I did 15 times 12. So I did 180, x to the 6th, y to the 10th, z to the 13th. All right, and then from here is I just did like all the other problems. Now I started canceling. Okay, the 50 and 180, obviously I canceled that down to be 5 over 18. So 5 over 18. Now this is the first time that we've had all the x's canceled, so they're gone. Because if I wrote out 6 on top, 6 on the bottom, gone. Y to the 5th on the bottom, z to the 8th on the bottom. Final answer. Now, just another approach that you could have done, and maybe you did this, you could also cancel like the first fraction, for example, like this. Okay, I took the first fraction and I did 2 over 15, okay, x to the 2nd, y to the 4th, z to the 2nd times, now here I could cancel, nope, nothing, 25, 12, x squared, y, z to the 6th. And then I could, what I would do from here is I would cross reduce my fractions. 2 goes into 2 once, 2 goes into 12 6 times, 5 goes into 25 5, 3. So I had 5 over 18, and then I would do my top, I still had x squared, can cancel with x squared, and then I had y to the 5th, z to the 8th. So there's lots of approaches as long as you got the answer. Now, obviously, we're going to have to practice some of these harder ones a little bit more, but here's what I need you to do today. Just like last week, you have 4 problems, and I want you to do these 4 problems first, okay? Or put it on a separate page, and I want you to scan it in first so that I can grade them, because I want to make sure we've got this. All right, so here we go. Number 1, let's go x7, y2 over x10, y. Number 2, let's do negative 10, x to the 2nd, y to the 4th, z to the 7th over 4 squared, x to the 7th, y to the 2nd, z to the 12th. Number 3, we're going to try one with, let's do another one that's a little bit easier. Let's do 4 to the 2nd, 3 to the 4th, x to the 7th, y to the 10th, over 4 to the 5th times 3 to the 7th, x to the 10th, y to the 15th. And then this one. Ready? Let's go 3x squared, y to the 3rd, z, all squared. Oh, actually, let's make that a cubed. Over, ready? 9x to the 5th, y to the 2nd, z, all squared. All right, so once you're done with that, if you would submit this first so I can check those 4, and then we'll practice some more tomorrow.